And I welcome the contestants Vishnu Prabhavi, Akshay Venugopal, Gayatri Ramesh, and Richard Joseph. And well, I don't want to take too much of your time. So once again, a very warm welcome to each and every one of you. Thank you.
Thank you, Surjit. Now let me invite our session chair, Mr. Akhil PV, who is working as an assistant professor in the School of Engineering, CUSAT. He did his BTech in Information Technology and is currently a research scholar in computer science at the School of Engineering, CUSAT as well. He did his MTech in computer science and information systems from the Federal Institute of Science and Technology under the Mahatma Gandhi University. I welcome you to be the session chair for today.
Thank you.
Begin with our student exercise 12. Our first speaker of the day, Akshay Venugopal, BTech Information Technology student from University College of Engineering, Karivetta. He has an industrial knowledge of healthcare management systems. He is also a part of Workspace community team. I welcome Akshay for his presentation on the topic contactless payment.
Hi, good evening. Am I audible?
Yes. Yes, you are.
So let's start. Good evening, Akshay. I'm a UCK student, IT branch, first year student of IT branch. So is it visible?
Yes. To me.
Yeah. So let's start the contactless payment. As the word itself refers, contactless, which means we does not need to put our card to physically make contact with the card reader. It can also be called as tap-to-pay technology, or the kind of technology that we use at the POS, which is the point of sale terminal, which uses wireless technology. We can identify this technology on our credit cards by looking at the Wi-Fi symbol, which is located on the front or back side of every card. You can see in the picture that it represents a Wi-Fi symbol in which this card is a contactless card. The technology used in the contactless payment. First of all, the main technology used in contactless payment are the artificial intelligence, which is a widespread mode used in the contactless payment. Next comes the RFID. The RFID, which means the real radio frequency identification, which uses wireless non-contact radio frequency base, which is used to transmit data wirelessly. As we all know that the RFID technology is being used in a FASTag payment, which is being implemented all over on our national highways across India. Next comes the NFC, Near Field Communications, as it is a method of wireless data transfer that allows smartphones to share data in a close proximity. NFC is also similar to radio waves, but it is limited to sharing data with other devices. The distance between the NFC to communicate is about 2 to 4 inches. As we all know that RFID, we can look at the images. We classify the RFID reader as the POS machine and the object as the credit card. By simply waving our credit card across the POS terminal, it transmits all our information wirelessly in the form of radio waves through which the payment is done. Next, how does contactless payment work? Contactless payment have a chip which emits radio waves. An antenna is also built into the plastic to secure the connection with the contactless reader. As we can have a look on the picture that there's an IC chip embedded the antenna in the plastic card, in which it can be classified as a contactless smart card. To pay for something with a contactless credit card, just hold your card near a payment terminal or the POS machine. Wave your card across the terminal and you're ready to go. The payment is done as fast as simple. We can have a look at the picture that the Wi-Fi symbol, which is the contactless payment system. Wave, just keep our card over the POS machine. When it beeps, green light blinks, you are ready to go. The payment is done. the devices used in the contact. Many of the technological devices that we use in our day-to-day life, for example, smartphones, fitness trackers, watches, wristbands, key fobs, etc., all consist of the contactless payment system. As we all know that the Apple, which is one of the famous smartwatches in the world, also has the contactless payments facility in which we can do our payment instantly across the stores. Next comes the use of contactless payment. Where can we use this contactless payment? We can use this contactless payment across the supermarkets, restaurants, in the coffee shops, in the public transport. For example, in UK, we can use payment in train for our journey. In automatic vending machine, which we can have the toll receipt across the. Next comes advantages of contactless payment. From the perspective, we can have a wide variety of advantages across the contactless payment. First one is ease of use. Quicker transactions and shorter queues at the checkout are the most significant advantages of the contactless payment. Handling cash is not a concern at the checkout, but having a hassle-free payment system is one of the most important use in the form of contactless payment. Safer transactions. The tap-to-pay technology is more reliable and secure than other form of payment. The chip technology protects against any other fraudulent purchases. Better operational facility. Adopting tap-to-pay technology is faster with lesser workforce requirement. It reduces the time that we spend operating the card or counting cash, etc. at the counter. No extra cost. Providing a contactless payment technology does not attract any additional processing fees. The retailers pay the same fees as application. Next, we can have a look at the challenges faced on contactless payment. Despite every kind of technologies we use across our day-to-day life, there might be some kind of challenges or disadvantages in our day-to-day life. One of the major concerns is the low transaction cost.
scenarios and maximize yields without requiring any additional resources, and thereby reduces costs dramatically, which will further increase the overall profits by manifold. AI can simplify crop selection and help farmers identify what produce will be most profitable, and this kind of analysis of market demand can be really useful for the farmers. Third of all, to reduce downtimes in case of farming equipment failures, agribusinesses can use AI to monitor equipment performance and notify maintenance teams about upcoming failures. Finally, regarding alignment with sustainable farming practices, the concept of sustainable agriculture revolves around finding a way to meet current food needs without using up too many resources and leaving the next generation with nothing. AI helps farmers find sustainable patterns of resource consumption to avoid water scarcity and land degradation. Just like any other thing, everything with AI is also not rosy. Let's now look at what are the major challenges that lies ahead in our path. Firstly, the lengthy technology adoption processes. Farmers need to understand that AI is only an advanced part of simpler technologies for processing, gathering, and monitoring field data. AI requires a proper technology infrastructure for it to work. So, software companies should approach farmers gradually, giving them simpler technology first, maybe like an agriculture trading platform. And once the farmers get used to a less complicated solution, they can step it up and offer something else, including AI features. Secondly, there is still lack of experience with emerging technologies. The agricultural sector in developing countries is very different from the agricultural sector in Western Europe or the US. Therefore, the tech companies hoping to do business in regions with emerging agricultural economies like India, so they, in addition to providing their products, they will also have to provide training and ongoing support for farmers and agribusiness owners who are ready to take on innovative solutions. The final and the most important challenge, I believe, is the existing privacy and security issues. So, since there are no clear-cut policies and regulations around the use of AI, not only in the case of agriculture, but in general, precision agriculture and smart farming raises various legal issues that often remain unanswered. Privacy and security threats like cyber attacks and data leaks may cause farmers serious problems. Unfortunately, many farms are vulnerable to these threats. So, as a conclusion, we can sum it up as AI can be appropriate and efficacious in agriculture sector as it optimizes the resource use and efficiency. It solves the scarcity of resources and labor to a large extent. Adoption of AI is quite useful in agriculture. Artificial intelligence can be technological revolution and a boom in agriculture to feed the increasing human population of the world. Artificial intelligence will complement and challenge to make right decision by farmers. So unquestionably, the agricultural sector needs a greater impetus from policymakers in addressing the aforementioned challenges. And as you guys saw, AI is a possible way forward in increasing the economic and environmental stability of agriculture. Certainly, AI is not without its own shortcomings, but then everything has its own advantages and disadvantages. Thanks to our augmented capabilities for changing our world dramatically, we are going to have a world with more variety, more dynamism, more adaptability, and of course, more beauty. It is not going to be anything like what we have ever seen before. Why? Because what will be shaping those things is this new partnership between technology, nature, and humanity. That to me is a future well worth looking forward to. Thank you all.
Thank you, Gayatri. Now the platform is open for questions.
Okay, hello Gayatri.
Hello, sir.
Okay, I think you started off by saying that you had submitted a proposal which got accepted in the Kerala Startup Mission, correct? correct?
Yes, sir.
It was some work related to AI in agriculture, right?
Yes.
Okay, okay. But you have not actually mentioned anything regarding that work here. You just summarized what are the prospects of AI in agriculture in this
Yes, sir.
session.
Actually, we are still in the ideation phase. We just signed the MOU with the university.
Okay, okay, fine, fine, fine. So, yeah, I think you pretty much covered what are the things that are yet to come in the field of agriculture with AA and all. Mostly it is adopted in some of the Western countries already. It is yet to be in a full-fledged in our country. So when you have covered the different uh, advantages and applications of these things, have you really thought about what challenges it might actually cause in our country? Because the challenges specific to our country is different from what is there in another country. For example, people working in agriculture industry in our country mostly maybe from very rural areas, and they are not that exposed to new technologies and all. So when we try to pitch something new to them, it is really difficult to make them understand and implement those things, right? So have you thought
Yes.
about that part, and how we can bridge that gap so that it can also like reach them? Have you thought about it?
Sir, initially when we were talking about this product, we thought we'll build it something based on a smartphone app, and later on we just realized that okay, these farmers are from rural areas and many of them might not be even having an access to internet. So what we are trying to build and implement is something that that will be fully automated, and they can even access it with their 2G phones without even the usage of internet. Certainly maybe introducing them this to this and educating them will be the toughest part, but along with introducing this product, I think the more than investing on the product, I think we need to put on more investments to actually educate them first of all.
Correct. So there is two aspects actually. One is like educating them or making them know about these things. Secondly, we should, like you said, the basis of the whole thing is data, right? So we should have a fairly good amount of data regarding a particular crop and an area, so that we also can give good predictions, right? So it might take a few years. Like first we have to educate them, then we have to introduce our tools, then it has to be in use for a few years, and only then we can come up with good predictions. What do you think? It might take another like 2 to 3 years.
Absolutely, sir.
Okay. Okay. I think your presentation was like well organized, and like you tried to include almost all the aspects. I thought you might miss about the challenges, but you were like uh, keen enough to include that as well. So it was good.
Thank you so much.
Yeah.
Good evening, Gayatri. I am George.
Sir.
How frequently you use the word user friendliness when you are developing a module? What all things you take care to see that your product is user friendly?
First of all, what we are trying to build, yeah, we always believe in the ideology that the user is the king. So while we are making this, we are still in the ideation phase only. We are still researching about this product, and we are trying to make it as automated as possible, so that they won't have to deliberately know much of the technological stack to and we are like trying to develop an to integrate something that will suit with their own requirements.
Okay. Thank you.
Thank you, sir.
Here we can call the next person.
Okay, ma'am. Moving on to the next speaker, Vishnu Prabha, a research scholar at the School of Engineering, CUSAT. Her research work is on the topic automatic legal text summarization. She has done her internships with various reputed companies. Her areas of interest are big data, Internet of Things, natural language processing, and deep learning. I invite Vishnu Prabha for her presentation on the topic deep learning for NLP. Thank you.
Yes, it is.
Okay. Myself, Vishnu Prabha, research scholar at Cochin University of Science and Technology, and here to give you a short presentation on deep learning for natural language processing.
Your voice is breaking. Your voice is breaking, Mr. Prabha.
Some audio problem is there.
Okay, am I audible now?
Yeah, now it's coming. Yeah,
Okay.
fine.
Okay, here is the overview of the contents. First, we will go through an introduction about NLP, what is natural language processing. Then we will discuss the engineering approach to NLP. And finally, deep learning structures for natural language processing. It includes recurrent neural network and encoder-decoder network. So, moving on to introduction. All of you must have heard of applications like Google Translate, Amazon's Alexa, Google Assistant, etc. All those are applications of NLP. In Google Translate, we convert text from one language to another. Okay, so in that case, we are giving text data as input. In case of Alexa, we say, Alexa, play cat music or something else. In that case, Alexa processes the voice information and perform a specific action. Okay, so mainly there are two kinds of input to a natural language processing unit. One is voice and another one is data. Okay, now let's see how this natural language processing unit works. Theoretically, for processing natural language or understanding natural language, we have to know the meaning of the text, right? For computers, it follows a sequence of steps for understanding the language, like syntax analysis, semantic analysis, morphological analysis, etc. But practically, it is not like that. It goes through three different steps: pre-processing, text-to-vector conversion, and model creation. For example, in pre-processing stage, it cleans the data or prepares the data for further processing. Consider a PDF file. I just want the contents of that PDF file. So in the pre-processing stage, I'll be removing the headers, footers, special characters, page numbers, etc. all and other metadata from that PDF file. That is what I'll do in the pre-processing stage. But it is not same in the case of all application. It differs depending on the input and application. Okay, next step is text to vector conversion. In that case, text to vector conversion unit receives a string of words as input. So a computer cannot understand text data. So we must convert that text data into vectors or numerical format. So in text to vector conversion stage, we convert words to numerical values. It is also called the vector of a specific word is called as a word embedding. Okay. Next step is model creation. Models can be created for doing NLP tasks such as syntax analysis, semantic analysis, sentiment analysis, summarization, etc. So models can be created using two different methods. One is with training data and the other one is without training data. If we are creating models with training data, then we can use technologies like machine learning, deep learning, etc. But if we don't have any training data, then we can go for rule-based methods or any other probabilistic methods. So moving on to deep learning frameworks. Today we are discussing about deep learning structures used for natural language processing.
So before that, we must understand what is the difference between a neural network and a deep neural network. In case of a neural network, we have a single hidden layer. Okay, neural network consists of an input layer, output layer, and a single hidden layer. Whereas in deep neural network, it consists of more than one hidden layers. Okay, that is the first difference. And another difference is while training. In case of neural network, say for example, I have a problem. And the system should identify whether the input is a how are you question or not. There are various ways of asking a how are you question. Okay, so the system should identify whether this question is a how are you question or not. So if I'm using a neural network for that, then here I have given 6 different ways of how are you, asking how are you questions as training data, and along with that I'll be giving some features. Okay, that is the input to a neural network. Whereas in case of deep neural network, I'll be giving only training data, but the amount of training data should be large so that the deep neural network can automatically learn the features from that training data. Okay, next one is deep learning models for NLP. For NLP, we are commonly used models are recurrent neural network and encoder decoder network. Recurrent neural network is a feed forward network with a feedback loop. Here you can see that the feed forward network consists of a hidden layer. It consists of 2 neurons, but there is no connection between those neurons in the hidden layer. Whereas in case of recurrent network, there is a connection between the neurons in the hidden layer. So that is why this recurrent network is able to handle sequential data. Okay, so in natural language processing, we are using sentences. Okay, sentences are in the form of sentences can be considered as sequential data, and recurrent neural network is more appropriate for handling sequential data when compared to other neural networks. Of course, you can use CNN network and all for processing NLP, but RNN is giving much better results. But RNN have a problem. For example, RNN cannot handle long sequences or sentences. For example, I have a question answer generation problem, and the question I'll give a question as input, and the system should generate an answer. But if I give a question, the recurrent neural network should be able to read that full question, and then the system should give an answer. But in case of recurrent neural network, it can't remember long sequences, and it can remember only the last 2 words of that question. Okay, that is the main issue with the recurrent neural network. So in order to solve that problem, we are using encoder decoder network. In encoder decoder network, we are using 2 recurrent neural networks. Okay, first recurrent neural network is used for encoder, and second one is used for decoder. And that too, the input from the hidden states from the recurrent first encoder neural network is given as input to the output from the encoder network is given as input to the decoder network. Okay, so there are different types of RNN. RNN can be used for various applications. Today, while writing an email in Google, we will get predictions for the next word. All those applications are based on this RNN. Okay, there are different types of RNN. First one is one-to-one. In that case, I am giving wrote as input, and the RNN will predict the corresponding parts of speech tag of that word. Okay, and another one is one-to-many. In that case, this one-to-many RNN network is mainly used for question generation. If I, that is MCQ question generation and all, if I give a single word as input, it will generate the question. Okay, next one is many-to-one model. In that case, I am giving a sentence as input, and it will predict the tense of that sentence. In case of many-to-one model, we are predicting the next words. Here, when how is given as input, it will predict the next word it, and if it is given as input, it will predict the next word going. So if we have only single sentence starting with how, then it will predict like this. If we have more than one sentences starting with how, then it will have many suggestions. Okay. So moving on to the encoder-decoder network, as we already discussed, RNN cannot remember long sequences. So in order to solve that problem, we are using an encoder-decoder network. I'm not going into the details. This encoder-decoder network is used for summarization. Encoder-decoder network can be used for various applications like Google Translate, all those things. Here we are using it for summarization. Here I'm using an Amazon review. Nice charger, works great. That is given as input to the encoder, and it will create a sentence vector. The encoder will create a sentence vector, and on the decoder side, this sentence vector, and along with that, internal state vector and a single word stat is given as input. So this when stat is given as input, and along with that, if that RNN network receives the other two inputs, it will start predicting the word. So great, then great is given as input to the next neuron, and it will predict the next word, charger. Likewise, that is how an encoder decoder works. So encoder decoder can handle sequences. That's all. Thank you.
Thank you, Vishnu Prabha, for delivering such an insightful talk on deep learning for NLP. The floor is now open for questions.
Hello, Vishnu Prabha.
Hi.
Yeah, I understand that you have taken up a very challenging job of discussing deep learning in NLP for like 10 minutes.
Okay. Thank
Yeah,
you.
in the sense, it is really difficult to put something into perspective in such a short amount of time. Your work is, I think in the beginning, regarding your introduction, it was told your work is based on text summarization in legal documents, correct?
Yeah.
Yeah. So what I understand from my understanding, so the kind of language they use in legal documents is quite different from what we use in our normal English language, right?
Yeah,
They have
exactly.
their own words. Yeah. So.
Yeah.
Can you share some challenges that you actually have when you are working on such a document? Like
Yeah, of
you have
course.
the challenge of getting the data and training it, right? Because the
There
commonly
is
available data does not suit this purpose, right?
there's no challenge in getting the data. Actually, the judgments are available online, but the challenge is that it is available in PDF format. So we have to clean it, and that is actually the issue. There is all documents are different, all judgments are different, and we cannot apply a general cleaning process for all those documents. For each document, we have to apply different cleaning methods. That is the main challenge.
Okay. So if you were to propose something as a universal thing, it is quite difficult, right? Because
Yeah.
the nature of the document differs.
Yeah, I'm trying to do
like
it.
Okay.
Okay. Thank you.
One more general question regarding the NLP.
Okay.
There is a thing called as we do give sarcasm and all, right? Sarcasm.
Okay.
Like irony. Yeah.
Yeah.
So it is quite challenging to recognize a sarcasm while working with NLP, right?
Yeah.
Because so have you come across any kind of work where they have actually somewhat able to like meet the problem as in identifying a proper sarcasm or irony?
No. Yeah, we can handle all those problems, but only with large amount of training data.
Okay.
With deep neural network, we can handle all problems, but we need a large amount of training data. Then we can handle all those problems. Because in NLP, it is difficult to detect a feature. For example, in neural network, we are giving features, right? But in an image processing and all, it is very easy to detect features and give a feature as input. But in case of natural language processing, it is not easy to detect a feature and devise a rule. A feature set detection and writing a new feature set is not an easy task in NLP. We have to, because we have to write grammar rules as features. So finding grammar rules for all sentences and or finding grammar rules for all patterns is not an easy task. So devising feature set is difficult in case of NLP, because we like I already said, how are you? How are you can be asked in different ways. There are different ways of asking how are you. We can't write a grammar rule for that. So writing features is very difficult in case of NLP when compared to image processing and all.
Okay, sure. That helps.
Thank you.
Lastly, we have Richard Joseph, who is a computer science engineering student at the University College of Engineering, Karyavattam. He's an avid reader and is an ardent technology learner. Apart from academics, his passions lay in video editing and photography. He envisions to be a great orator and has also been a part of the Gavel Club and Toastmasters. I welcome Richard to deliver his talk on the topic blockchain and cryptocurrency.
Hello, am I audible?
Yes, you're audible.
Yes,
Um, so, is it presenting?
Yes, it is.
Okay.
Yes.
So, good evening, everyone. My name is Richard. I'm a computer science engineering student studying here at University College of Engineering, Karyavattam. And I'm very grateful for receiving this opportunity to talk for the CSI Trivandrum Chapter's Tech Talks. And I'll be talking on the topic blockchain technology. So I'm pretty sure everyone has heard of blockchain technology. It is very popular. It is being featured in many articles and reports and is considered to be 21st century's most revolutionary piece of technology. But many people lack the idea or knowledge of what the technology in blockchain technology is. And so today I'll be answering the question, what is blockchain technology? So to answer the question, I feel it is much simpler to answer if an example is involved. So let's think of an example. Like, let's take an example of 6 students living together. Now, 6 students living together naturally will cause a lot of expenses. There's the rent, water bill, electricity, food, commodities, etc., etc., etc. So it's not always possible to split the bill, collect the cash, and pay it all together. So it's most of the time paid by a single person, and that person writes the amount and what was transacted in ledger, and the ledger is calculated at the end of the month, and people get to know how much they're supposed to pay someone else or how much they're supposed to get in return at the end of the month. This system is what many people use nowadays, and that is the common system that we use. But it depends highly on the trust that each of the person has for another person. It trust plays a very pivotal role in this type of system, because if you don't trust the other person, I'll give you an example. If one of the people out of the 6 students went out to buy snacks, and he bought snacks for 100 rupees, came back and wrote in the ledger 150 rupees. Now, at the end of the month, when the ledger is calculated, he's rewarded with an extra 50 rupees. So he's rewarded an extra 50 rupees for his malpractice or foul play. So this problem arises in dealing with this system. So how do we solve it? We have to change the system. While changing this system, instead of giving a single ledger for the whole party of 6 people, why not give one ledger to each of them? So right now, there is 6 ledgers in total. So when the person goes out to buy snacks for 100 rupees, he not only has to write the details of transaction in his ledger, but in everyone's ledger. Let's also put another condition forward, where we can only write in this ledger when the transaction is authorized or verified, or there's some sort of verification. So now this makes it almost impossible to do any sort of malpractice or foul play. It's much more secure than it was before. So this system is more of a decentralized way of working. It's a decentralized system. The first system in which I talked about was more of a centralized system in which there was only a single ledger for the whole group of people, and the other one, each and every one involved had a ledger. So that is a more of a decentralized way. So now in the second system, if he has to do any sort of malpractice, he will have to manipulate the data in not only his ledger but in at least a majority people's ledger. So let's say if there is 6, he has to manipulate the data in at least 4 people's ledger. Then only will it be taken into consideration. This is called the consensus method. So this decentralized system is the basic idea of blockchain technology, and this is the very basis of blockchain. So IBM defines blockchain as a shared immutable ledger that facilitates the process of recording transactions and tracking assets in a business network. An asset can be tangible or intangible. Tangible assets being houses, car, cash, land, etc. And intangible being intellectual properties, patents, copyright, and branding. So recently, using the blockchain technology, a lot of artists sold their art pieces as NFTs, non-fungible tokens. And this was a very successful implementation of blockchain technology. And a lot of artists got a lot of money for their art through blockchain. So virtually anything of value can be tracked or traded using the blockchain network. And it also reduces the risk of malpractice and also cuts cost for all individuals involved. So now that we have understood a basic level of understanding of blockchain technology, let's have a very revamp of a very brief history of blockchain technology. So like the name indicates, blockchain is a chain of blocks that contain information. This technique was originally discovered in 1991 by a group of researchers. And it was originally intended to timestamp digital documents. So it is not possible to backdate them or tamper with them. So it was discovered by researchers so that foul play will be. But even was in it, people never really use.
Audio missing. Audio missing.
It was adapted in 2000. Digital high.
Audio is discontinuous.
Richard, your audio is breaking with that.
Okay. Is it okay now?
No.
Yes, yes,
Is it okay?
yes.
Okay. So till where did it start becoming disturbing?
Last 2 or 3 sentences.
Hello? Oh, okay. Really made blockchain very visible to the mainstream. It brought people in and people started learning about it. And blockchain basically is a distributed ledger that is open to all, and they have some interesting property. So once some data has been recorded into the blockchain, it is very difficult to change it. So how does this work? How does this property work? So well, let's take a closer look at a block. So each block contains some data part. Second element, the hash of the block, and the third element, hash of the previous block. The data stored in a block depends on the type of blockchain it is. So for example, if we're taking a Bitcoin blockchain, the stored is the details about the transactions. For example, the sender, receiver, and the amount of stored in it. So now second element, a block also has a hash. You can compare a hash to a fingerprint. It identifies a block and all of its content. It's always unique, just like a fingerprint. Once a block is created, its hash has been calculated. Changing something inside the block will cause the hash to change. So in other words, using hash is very useful to detect changes in the block. So if the fingerprint of the block changes, it's no longer the same block. Now the third element, the hash of previous blocks are stored in the block. This effectively creates a chain of block, and it's this technique along with the proof of work that makes the blockchain too secure. So for example, The hash of the previous block, when it's stored, effectively creates a chain of blocks. And that's why we call it blockchain. And proof of work means the delay of time it takes for a new block to emerge, a new block to be created. So, for example, in Bitcoin, it takes 10 minutes to create a new blockchain. So, along with yeah, so it takes 10 minutes, and therefore consensus method, hash of previous block, and proof of work makes the blockchain very secure. So now, to talk about some benefits of blockchain, the benefits of blockchain, if introduced into an industry, is better transparency. So many organizations have issues with transparency, and they look to improve transparency. But no matter how many rules or regulations that are put into place, there is one thing that doesn't make any system 100% transparent, and that is centralization. As long as the organization is working on a centralized system, it is never 100% transparent. So putting a blockchain technology in an industry will make it much, much transparent. Enhanced security. As we discussed, blockchain technology utilizes advanced security compared to other platforms or record-keeping systems. Any transactions that are recorded needs to be agreed upon according to the consensus method. That means the majority of people should agree. Then the majority of blocks should agree. Then only will the transaction will be recorded or put into the block. So each transaction is encrypted and has a proper link to the old transaction using hashing method. So the next benefit is reduced cost. This is a big one because organizations always look for profit, and implementing blockchain technology into their organization will completely eliminate any third-party vendors. And therefore, there is no need to pay any third-party vendor because blockchain works from peer to peer. It is from one person to the next person. There is no need for a middleman, and that will cut costs significantly for organizations, and that is a benefit. The next benefit is true traceability. See, we discussed about this interesting property of blockchain, that once the data is stored in a block, it is very difficult to manipulate or change it. So within a blockchain, if it is enforced, creating a supply chain that works with both the vendors and suppliers is very, very good. And the traditional supply chain it's very hard to trace items, and it can lead to many problems, including theft, counterfeit, and loss of goods. But in this, because of that special property, all the data is stored and cannot be manipulated. So we know exactly the correct data, how the product is from its origin to how it has landed in our hand. Everything is stored. Now it also removes the next benefit, removes any human errors. It improves speed and it is highly efficient. So this is the last industrial benefit. Bringing blockchain improves the efficiency and speed of blockchain, speed. So blockchain solves the time-consuming process and automates them to maximum efficiency. It also eradicates human-based errors with the help of automation. So I would like to end by saying a quote by Melanie Swan in her book, Blockchain Technology, The Blueprint for a New Economy, in which she said in her concluding statements that blockchain technology could be quite complementary in a possible space for the future world that includes both the centralized and decentralized models. Like any new technology, the blockchain is an idea that initially disrupts, and over time it could promote the development of a larger ecosystem that includes both the old way and the new innovation. So like before, when radio and motion picture were introduced, radio system was highly adopted. That has now in the future. The radio ecosystem, and there is the motion picture and color TV ecosystem. And right now in the future, we have a wider ecosystem of both the old way and the new innovation. My speech. Thank you.
Thank you, Richard, for your presentation on a prominent topic. So now the platform is open for questions.
Hello, Richard.
Yeah.
You did a great job in like capturing the essence of the technology in your presentation, like in such a short time. First, it was told like blockchain and cryptocurrency. I wanted to like specify something regarding that only. Like as you said, blockchain has kind of erupted now, and it is not just
Crypto.
like limited to
Yes, yes.
cryptocurrency. Yeah, but every time someone hears blockchain,
Mm.
the first thing that comes to mind is
Yeah.
cryptocurrency. Yeah. So can you add something more to that? As in
Yeah.
which all other areas you think it has like flourished, and why do you think it has got such a good application in that area
Mm.
other than cryptocurrency?
Always when blockchain is introduced in any article or videos, anything, it is always associated with cryptocurrency. While cryptocurrency is a very important and successful implementation of blockchain, blockchain technology is not limited to cryptocurrency. People have a false belief that blockchain is cryptocurrency, but it's the right opposite. Cryptocurrency is blockchain. Blockchain can be implemented in any way. It can be implemented, like I told, in industries. People and businesses could be having positive effects by implementing blockchain into their business model. So, for example, like another way is transactions, or implementing it in medical facilities, where people can directly communicate with the organization rather than going through a middleman. There's no need of a middleman. So it's not limited to cryptocurrency, but because cryptocurrency is it's the most popular and right now the most successful implementation of blockchain. That's why people always you know misinterpret it as the only effective way to use blockchain is cryptocurrency, but it can be used in many industries, almost any industry.
Yeah. So someone like told me, like it was some time back, like when the topic of discussion was on blockchain, it was like, see, whenever you like you have an idea of eradicating the corruption and all, if you can just implement the concept of blockchain, wherein wherever transaction is involved, there won't be any more corruption, because there is no way of faking something happening and like doing behind the scenes.
Yeah, yeah, that's true. Because blockchain is peer to peer. If you're, let's say, if you're doing a transaction or even voting, if you implement blockchain in government, I think votes would be much fairer, because there's no middleman, right? Because there's no middleman. You vote for a party or whatever it is, it goes directly into the data. There is no manipulation. If you have to manipulate, you have to manipulate each and every vote. That is not possible. You can only manipulate a few handful. So since there's no middleman, and you don't have to trust the people who are organizing, you just have to trust the technology. You just have to trust blockchain or how it is coded. You don't have to trust the human element of the piece. So that effectively removes any source of corruption from the scenario.
Okay. Yeah, so I think you have taken the effort to know this in detail, and so as to realize what all good things it can bring into the picture. Yeah, so thanks. It was a good question.
Thank you. Thank you.
I'm extending my vote of thanks. I would like to thank our session chair, Akhil sir, for his wonderful mentoring and valuable suggestions to our fellow colleagues. Thank you, sir. Thank you so much. Thank you, all the speakers of the day, for your wonderful and vivid presentation. Thank you, all the participants and faculties, for your active participation in the Student Tech Talk. Hope to see you all for our next Tech Talk series. Thank you all.